Hello and welcome to the next video. In this video, we are going to discuss a new classifier that is called a naive-based classifier. In the previous section, we had discussed about the little bit about the decision tree, and we have write a code for the decision tree. So there was some issue in the decision tree. The first thing, if we talk about in the case of advantages of the decision tree, it's easy and usable in without too much preparation. So that is the main thing for that. And the other thing is to we can check the decision tree without too much preparation of data. And another, if we talk about the disadvantage of the decision tree, uh, as we have seen in our practical section, the decision tree overfitting was a common problem. So this was a common issue. So to tackle all this stuff, and also the another option, the issue in the decision tree is we have to make our data set proper balanced sampling of the data set as very common. And today we are going to discuss a knife based classifier. So this is not actually only the one algorithm or one, uh, we call it a model. It is a collections of algorithms, and it totally works on the Bayes theorem. And using the Bayes theorem can help us to find the probability of A happening given that B has occurred, whereas B is the evidence and A is the hypothesis. One feature does not affect the others, meaning that both are independent. And all, as we know, all the features are independent. All the features have the equal contribution to the outcome. And if we just go down a little bit, here is the Bayes theorem. We call it a formula or Bayes theorem, where the p, the probability of A given by B, is equal to p, B given by A time or multiply p, or and A, and divided by p B. So this is the general formula for the Bayes theorem. If we convert the same formula in our dataset case, it comes like in this way, where p y given by x, y meaning that our outcome, x meaning that our attributes or columns, is equal to p, probability. By the way, the left side, the p and y given by x, we called it a purchase probability. And in the case of right side, p x given by y, that is we called a likelihood. And time p y, this is called a prayer. And divide by p of x, and that is evidence of the features or the things, right? So before going further, let's say that if we, like in our data set, I have this data set here. I have this data set, and I just picked it somewhere from the Google. So here we have almost 14 records, and the feature column are, the outlook, temperature, humidity, windy, and play golf is our outcome or target column. In the case of outlook, we have rain, overcast, sunny, and I believe so. These are the three columns. The three value, possible value in the outcome. In the case of temperature, we have hot, well, and cool, three value in the temperature. And in the humidity, we have high and normal. That's it. And in the case of windy, we have true and false. Right. So if we go to here in our formula, so the x as we know it's our variable, I mean the feature variable that represent the x. So x1, x2, x3 and so on xn, right? And the substitution for x would be like this. As I said on the above, if we convert the Bayes theorem to the data set, it becomes the p y given by x and all that. So if we change, I mean put the value in the Bayes theorem with our data set, it becomes like this: p y mean outcome, given by the feature, I mean the list of our uh, x variable or the feature variable x1 to xn is equal to the same like that p x1 y, and then p x2 y and so on to p n given by y and in the last py, and same comes over here p x1 multiplied p x2 and so on to p xn. So when we put the our data set, so the formula becomes like this. Okay, so what I have did over here, we need to find the p xi and given by y for each xi and x and yi in y. All these calculations has been demonstrated in the table. So what I had did, here is the table. Suppose in the case of outlook, we have sunny, overcast and rainy, the three value in our outlook column or in the outlook feature. How many sunny we have in the table? We have two sunny, three I mean no. We can check that on the outlook: one, two, three, four and five. Total five sunny. One was no, and the another is yes, and no, and two yes, and yes, and there is also one no. Here is the one no. So if we put the value, the total yes are 2 and total no are 3. So how many occurrence of yes in the whole play golf? So here is that your our column, I mean the target column. If we come over here, we can check that 1, 2, 3, 4, 5, 6, 7, 8, 9. We have total 9 yes and I believe so 5 no. 1, 2, 3, 4 and 5 no. So when we put the value, it comes like total sunny in the case of yes is 2 and total sunny we know the total sunny is 2 divided by total yes. As we have just calculated, total yes are 9, and in the case of no, the probability of no is equal to 3. 3 are no and divided by 5, that are the outcome value of our no, right? And same like that the overcast and same like that. So what we have we have total 9 yes and total no 5. When we sum up this, it will come to a 14. And the same like for the temperature. If we come on the temperature, how many value we have all the value in the heart, and I have made it here. The total heart is yes and no are 2 yes 2 no, so 2 by 9 and 2 by 5, and the mild also have the 4 2 and all that. So it always come like this. And in the case of humidity, it seems like the normal and high, the 3 and 4. So 3 divided by 9 and 4 divided by 5. And in the case of normal, 6 are yes, one is no, and 6 by 9 and 1 by 5. And in the case of windy it will become the same. So the play golf, like I had on the above we have counted the total yes in our target column. I mean, here is our target column, yes no, because this is a binary classification, like we are just predicting the yes or no. But in the case of multi classification, suppose we are discussing might be the colors of something, there could be a color red, green, blue, orange, whatever, so that could be a different case. So the total play are yes are 9 and no are 5. So when we come over here, it becomes 100% like same. So when we put the formula in the case of p yes by today, today mean if we talk about the today, p and sunny outlook total yes by given yes, and p hot temperature given yes, p normal humidity given yes, and p no wind given yes, and p if we have another humidity then yes, the same like this, and divided by p today. In the case of no probability given to the no, no, if we, over here in our column, in our target column we have only two value, yes and no. So we have to check our feature column, comes to the 0, I mean x come to the no and yes. So we have to check the x mean the feature with the both value no and with the yes. So that's why we have yes and no, right? So the same like that, when we put the value p yes today, how many sunny we have? 2 by 9, 2 by 9, 6 by 9, 6 by 9, and 9 by 14. The same like this in the case 6 by 9, right? And all comes this way actually. When we put the value for the 2 by 9, we are calculating the yes for the outlook, and if we come to the outlook we can see that 2 by 9, right? Then the forecast, and then the rainy, and all this stuff we will come like this, and it will comes to the, when we multiply all this stuff, so it comes to the 0.0141. and the case of no, we will check that this value, and we have over here in the case of no 3 2, and we will check that 3 5 and 2 5 and all that. No, we have to calculate yes plus no. When we calculate all this, it will come like this. P yes, how many P yes we have? We have 0.5, right? And P no, we have this value. Why this value? Because in the case of yes, we have total value 0.014. In the case of no, we have 0.068, right? So as I said in the formula, if we come to our formula, so it comes like this: pxx and px1 to pn. If we come to the exact formula, px and I mean p of x. So what are the possible value for the x? It is a two value actually, no and yes. So that's why we have added a value here. The yes, I mean the total yes is 0.014, 0.014 plus, because the x the outcome value for the yes or no, plus 0.068 is the case of no, right? When we plus this and divide by that, then the value comes like a 0.67. And in the case of no, it will also become a same way, right? The first value of no, then divide by plus of yes plus of no, it will come to 0.33. Since we can see that the value of yes of today is greater than to the value of no today, so the playing golf prediction is yes in the case of today. So this is the Bayes theorem, a Bayes naive based classifier that works for the classification problem. So the thing is that why we are using the Bayes classifier. I mean, why we need the this algorithm, despite of we have all the stuff for the other thing, like why we are using the naive based classifier. As we said, it is all the column, I mean all the feature column are independent, and it is very easy and very fast while comparing the complicated things, right, to calculate the things. And it works with the multi-dimensional data sets. Suppose in the case of text calculation, classification, email spamming, and detection, spam detection. So the another issue, I mean, if we talk about in the case of cons, or in the case of issues, or in the case of disadvantage, it is considering that the feature column are independent, like all the columns are independent, so no one is dependent to each other, not. So in the real world problem, it is not 100% sure that we will find things that works with the independent way. So the algorithm is less accurate in that case, because it speed up lot of cost in everything. So in general wording, the assumption that all the features are independent is not usually the case in the real life, right? So it make naive based algorithm less accurate, meaning that the accuracy of the algorithm is not 100% accurate. Accurate, then complicated algorithms speed up at the cost. So this is the basic theory and basic concept of the naive based classifier. And in our next video, we will try to write an algorithm for the naive Bayes in the Python language.